What's up, guys and girls? Welcome to trèSci Weekly, Episode 1. Thank you guys for joining us. I'm one of your hosts, Jonathan Ullman, alongside the meat cleaver himself, Tom Kaya.
Oh, man. Glad to be here, guys.
Yeah, glad to be here. For those of you who don't know, this is going to be our weekly podcast where we talk about all science news. We've got a good show planned for you guys today.
Good one.
Tom, how you been?
I've been good. Yesterday, watched the Super Bowl, obviously.
Nice.
I was the Patriots making a extra point away from winning $250. And then right after that happened, I read on Twitter by Neil deGrasse Tyson saying that the rotation of the Earth would cause the ball to move over a half an inch. Oof. And I think it was that half an inch that cost me the $250, but that's okay.
So you got jerked.
Yeah.
A little bit.
Can't win them all.
You can't win them all. Sometimes you can't win any of them.
Yeah.
If you're the Atlanta Falcons, at least.
That's true.
Great. So, yeah, I've had a pretty normal week. The Super Bowl, I watched the last half of it, didn't watch the beginning. Opted to play Super Smash Brothers instead. Yeah, other than that, week's been pretty good. We put out our intro video to this podcast last Monday. Want to give a quick shout out to Kyle for helping us put that together and for helping us put this show together. We received, I don't know about you, but I received nothing but positive feedback.
People were excited to get going.
So thank you guys for sharing and liking and spreading the word for us. We really appreciate that. Yeah, so I think we're just about ready to go.
Start off this show.
Yeah. So let's get right into it with the top 10 news stories of the week. What we're going to do now is we're going to just kind of read them off. They're not ordered in any particular importance. We will read the stories and then we'll give ourselves 2 minutes to discuss kind of what we think about them.
Yeah, so these are just 10 of the top news stories that we've found. They don't really fit any specific theme or anything like that. And the synopsis that we're reading isn't directly from the article, right? It's like just a brief summary that we came up with to get everybody on the same page.
Yep.
All right,
so let's get right into it. Number 1. Hawaii's Keck Observatory has received a significant upgrade in its ability to search for exoplanets, or planets orbiting stars other than the sun. The upgrade comes by way of a Vortex Coronagraph, a new instrument that helps detectors look much closer to the host star by redirecting the intense starlight. Previous methods would try to mask or block the glare of starlight, but the Vortex Coronagraph instead combines different waves of the light and effectively cancels them out. Dimitri Mawet, inventor of the new coronagraph, says, quote, "The instrument is called a Vortex Coronagraph because the starlight is centered on an optical singularity, which creates a dark hole at the location of the image of the star. Hurricanes have a singularity at their centers where the wind speeds drop to zero, the eye of the storm. Our Vortex Coronagraph is basically the eye of an optical storm where we send the starlight," end quote. What do you make of that?
So, you want to hit the timer for us?
Oh, yeah. Good call.
All right. So, this one, kind of interesting. We've been looking at exoplanets for quite a while now, and as technology improves, as we go along with time, we get to look at more and more exoplanets in harder to see situations. Like this one is saying now we can look closer to the stars because the way we're looking at it, we're blocking out that starlight. We can look at exoplanets that previously would be unseen.
Yeah.
So kind of cool. Obviously, we can learn a lot about planets and just astronomy in general by looking at objects like this. But it's also kind of funny because we're not going to an exoplanet anytime soon or ever, probably.
Yeah, probably ever.
So,
it's not in our lifetime.
Yeah, but it is kind of cool that we can look at these other planets from other solar systems.
I agree. To me, this struck me as a very noteworthy piece of news because I think this is really going to change the game as far as what types of planets we're able to look at.
Yeah.
Obviously, smaller Earth-like planets, which are probably orbiting closer to their host stars, are going to become available for us to sort of figure out their characteristic speeds, orbital speeds, and masses.
A lot of exoplanets that we've observed up to this point have been Jovian planets, gaseous planets, because we look at them because they had to be a certain distance away from those stars to actually look at them.
Yeah, and I think that this is kind of funny because I bet you that there are astronomers and engineers who are probably just kicking themselves. This seems to me like an instrument that is kind of a no-brainer, right?
Yeah, like, let's do it this way. Yeah.
Why didn't anybody think of this before? But, I mean, that's just goes to show you, right? That's Occam's razor. Sometimes the simplest solution is the one that makes the most sense, right?
Yeah, so using this technique, block out the starlight, look at more exoplanets.
Yeah.
It's a win-win for science.
Yeah. I wonder if they're planning to use this. I wonder if they're planning to use this more with exoplanets that they've already discovered to see if they get better resolutions on
or
them
finding
first.
New ones.
Yeah, or rather just starting from scratch and finding new ones.
I guess they would probably do both. I don't know what they would prioritize, but they'd probably do a little bit of both.
Probably a combination of the two, yeah.
Yeah.
All right, number 2.
Second news story.
Researchers from Harvard University may have figured out a way to force hydrogen into a metallic state, or maybe not. By squeezing it between the tips of 2 diamonds and ramping up the pressure to 4.9 million times the Earth's atmospheric pressure, scientists Ranga P. Diaz and Isaac F. Silvera claim their hydrogen became reflective, which is one of the key properties of metal substances. The implications could mean huge advancements in the field of superconductors, or substances that allow the flow of electricity with zero resistance. It's theorized that metallic hydrogen can act as a superconductor even at high temperatures, unlike other already proven materials that only achieve superconductivity at extremely low temperatures. The claims made by the Harvard researchers seem to have a fair amount of skeptics, however. Physicists Eugene Gregorians of the University of Edinburgh and Alexander Goncharov of the Carnegie Institution for Science in Washington, D.C., have doubts that the results presented in the single experiment are reproducible or enough evidence to draw such an important conclusion.
All right. So let's think about this one. A few things come to mind right away is that it's not for sure that it can be done. And a lot of the problem with this type of experiment we were talking about before is that you need a particle accelerator. That's what that means. You need a particle accelerator to actually achieve this sort of experiment, right? So it's tough to actually do. So they're saying, let's pump the brakes. It's one experiment that points to this. We don't know for sure exactly. But this would change the game. Being able to have a superconductor that would function at higher temperatures, not where you have to keep them at super cooled laboratory type settings in order to get the superconduction type of material. This would be basically a game-changing type of material that could have tons of applications based on what they claim that this superconductor would be.
Yeah.
So it does have lots of implications if it can be done.
Yeah, absolutely. I look at this and I think that this could be the beginning of a new slew of research that dives into superconductivity, and maybe we're onto it, right? Maybe we figured this out.
Yeah.
On the other hand, I think that it's definitely smart to not let our emotions get the best of us here, right? We're excited for the prospect of superconductivity,
Yep.
but it's still a long ways out. This could be an important first step, but I think that although theorized that hydrogen can enter a metallic state, I think that this is not necessarily an end-all, tell-all situation where just because it became reflective doesn't even necessarily mean that it became metallic.
They're saying this implies that, and yeah. So this is kind of the first time that they've done it, and they're saying this implies that. So we're still a little bit of ways away, but we'll come back to it as we hear more stuff about it, because it could be something amazing that changes the way we build all kinds of things.
Yeah, straight up. All right, number 3. It seems as though practice really does make perfect. According to a recent study by Kazuhisa Shibata and colleagues, overlearning, or the continued training of a skill after mastery, abruptly changes human brain chemistry so that learning something new cannot overwrite that mastered skill. The study was conducted by having participants orient lines on a screen known as a Gabor patch. Rather than retell the intricacies of the exact experiment, I'll liken the results to a more relatable scenario. For argument's sake, let's say I was given the task of learning to play Mary Had a Little Lamb on the guitar. Once I figured it out to the point of no longer improving each time I play it, I'll take a break. Next, I'm given the task of learning Jingle Bells on the guitar. If you were to test me on my performance the next day, I would likely do well with playing Jingle Bells, but would have totally stumbled while playing Mary Had a Little Lamb. However, if I instead overlearned to play Mary Had a Little Lamb, just by practicing past the point of mastery for at least 20 more minutes or so, in theory, I would be able to perform that song much better when tested. By using magnetic resonance spectroscopy, or MRS, to track brain chemistry, the researchers found that if you do not overlearn, the brain has higher amounts of glutamate-dominant excitatory. Glutamate is a chemical that makes your brain more adept at learning, but overlearning decreases the amount of glutamate and increases the amount of GABA, or GABA, a chemical that stabilizes the brain.
Yeah, this one's pretty interesting.
Yeah.
You want to start us up?
Yeah, let's go.
So, right off the bat, I thought about science teaching in general. Like, what do you need the students to understand? What's the core topic? That might be the thing that you overlearn. Like, the things that you really need to be good at, right? Mm-hmm. Whether it's science, video games, anything that you really need to get well, those are the things you need to do. And even when you think you're competent, you need to keep doing them to get good at them.
Sure.
But what this also says is that the thing you're going to learn after that then becomes slightly a little bit more difficult because you're kind of trained into what you were doing before. So I think it's important to look at these things, right? Because students even get confused with how should I study, where a lot of times cases like this would say just do more math problems, just do more, overtrain, and your brain will have an easier time remembering those things.
Right.
So maybe even coming back to it, overlearn, and then when you want to learn new things, you have to realize that you have to put a certain amount into it before you can even get anything out of it.
Yeah.
So it's very interesting thinking about learning.
Yeah. This to me seems somewhat intuitive.
Kind of makes sense when you think about it.
I mean, as far as my own learning has gone, I typically will forget about, anything that I learn within minutes of learning it, unless I really hammer it into my brain. So
that's why a lot of times they say read over your notes that day. You got to really learn that one topic so you can go on to the next one.
Yeah. It's interesting to think about what mastery of a skill sort of means, because in a lot of cases in the skills that I feel like I've learned, if I return to them later on in life, I feel like there is a new plateau that I can reach. So I might get something, let's say playing the trumpet or something like that.
Okay.
If we play the trumpet at 16 years old and get to a point where I'm no longer progressing at playing the trumpet, and then coming back, in a year later at 17 years old, I might find that there's a new plateau to reach, even though I didn't practice or do anything playing the trumpet in the interim. So I think that there's sort of just life skills that you can pick up on and increase kind of the threshold, if you will, on your learning.
And just a real quick thing to finish it off, kind of reminds me of that. You really just need to keep practicing even if you think it's perfect.
Yeah.
Because your brain just builds up patterns, and then as those patterns get ingrained in you, you kind of just do them instead of having to think about doing them. And then those things that are automatic allow you to pursue whatever you're doing in a better fashion.
Cool.
Makes sense.
Yeah, makes sense. All right, number 4. NASA has released a 37-page audit on its current status of the Mars 2020 project, the next iteration of a robotic rover mission to explore the surface of Mars, and the results are not looking too positive. Deemed overly optimistic by the Office of Inspector General, the Mars 2020 project appears to be behind schedule in the development and testing of many of its science instruments, such as the sampling and caching subsystem, which will, quote, collect core samples of Martian rocks and soil and place them on the planet's surface for retrieval by a future robotic or human mission, end quote. The rover is currently slated for a July 2020 launch, and it is imperative for NASA to hit this date. Due to the relative positions of Earth and Mars as they orbit the Sun, missing this launch window would mean having to wait another 26 months before the next opportunity arises. What do you think about this?
Start us up again?
Yeah, I'm going to forget that over and over again.
With this one, it seems like this is the case for almost any sort of space launch or rover mission, is that there's the sweet spot that you got to get it in. Mm-hmm. Like when the Earth is here and Mars is there, the mission only becomes feasible when they're lined up like that, like this is saying. So I think a lot of times things do get rushed a little bit just because of these time constraints.
Sure.
So I think they might cut corners somewhere. I have no idea how or where they would, but I think they'll find a way to get ready for this date. I think it's important that they follow through with their plans when to go.
Mm-hmm.
So I think that they will actually make their deadline, but I don't think they'll say that we cut these corners and did this and that. I think they're still going to pull it off as this is our project and we're going to do it this way.
Yeah, I hope so.
I mean, they could miss it.
Yeah.
I mean, but
two things. I think going into NASA's sort of budget will play a large role on whether or not they meet these deadlines, and I think that is actually up for question nowadays.
The actual budget they'll have for this mission.
Yeah, and so I could see them missing it. I really could. Okay. I hope not, but I could see them missing it. The other thing that I thought was particularly of interest in this particular quote that I'm reading here is that the sampling and caching subsystem will collect core samples of Martian rocks and soil and place them on the planet's surface for retrieval by a future robotic or human mission. So they're really doubling down on this idea of humans exploring Mars. And I'm pretty stoked about that. Like, you know, because for all intents and purposes, I think that is a far off dream, and NASA seems really gung-ho about us getting there, at least within our lifetimes, which is, like, super exciting to me.
Agreed. So part of their mission is taking the cores and leaving them on the surface, saying, we'll get them.
We'll get them later, yeah.
They have plans, you know, they're, all right, we'll see what happens.
We'll see. Number 5. It's no secret that fast food is not the healthiest of dietary choices, but a new study published in the Environmental Science and Technology Letters journal suggests that fast food packaging wrappers are testing positive for chemicals linked to having an adverse effect on health. The culprit chemicals are long-chain fluorinated chemicals known as polyfluoroalkyl substance, or PFASs for short, which are used to make the wrappers water and grease resistant. Because of the strong carbon-fluorine bonds, these chemicals tend to not break down so easily, and the prolonged exposure in humans has been linked to thyroid disease, kidney cancer, and testicular cancer. By using a technique called particle-induced gamma-ray emission spectroscopy, or PIGGY for short, researcher Laurel Shader and colleagues found that 46% of food contact papers and 20% of paperboard samples contain detectable fluorine, end quote. The study suggests that since composting these paper packaging wrappers is a viable means of waste removal for them, PFASs could potentially end up in gardens or food crop growing areas.
So, you want to start us up again? So, I think I'm kind of an expert on the fast food topics. We've had some stories in the past where people who I didn't even know would say quad stacker to me, which was the crazy burger at Burger King at the time, because everybody knew that.
Yeah.
I worked out a lot.
This is not a sponsorship.
No, definitely not. And then I would just eat all the food. Okay. So when you think about fast food wrappers, you open up your burger, they're pristine. They're not wet. They're not greasy. Those things resist everything. You know what I mean? Those wrappers, they do a good job at what they do, but now we're finding out that they do a good job, but they have this in them.
Yeah.
So definitely questionable. And in the article that I read as well, they said it would be about a penny per wrapper to just change the whole way they make them to make them not have these things.
Yeah.
And it does bring up concern because these things eventually end up in compost or landfills. Yeah. And then that could eventually get in groundwater or other things like they say. So I think the change is necessary.
Oh, yeah. I agree. I think it's a simple fix. I think that there's definitely an alternative wrapper or way to go about consuming these products. I mean, I just have a huge problem with the way that we distribute and eat food in America just in general. I think it's a little bit much for me.
It's definitely a growing issue amongst a lot of people, I think.
Yeah, I think we've just completely lost touch with how to make and prepare food for ourselves. I think that way too many people, especially our age and younger, just rely on fast food chains and fast food chain restaurants, things like Applebee's, which people seem to think are not fast food, but they certainly are. So yeah, I mean the food itself, the packaging, the whole
it needs to be reworked,
business idea, the whole thing needs to just go away, in my opinion.
Yeah, the idea of franchising all these restaurants seemed like a good idea at the time to make money, but now looking at it, like, the system is kind of not good for the consumer at all.
Yeah.
In many different ways,
Yeah.
but hopefully it changes as we go on.